24th March 1945. Operation Varsity. The Rhine Crossing. 930 hours. A Handley Page Halifax bomber struggles to maintain altitude. The four-engine aircraft is flying at maximum power. Airspeed is barely 140 knots. The bomber is not damaged. It is towing something enormous. Behind the Halifax, connected by a steel cable approximately 150 meters long, flies the largest glider ever built for military operations. General Aircraft Hamilcar. Wingspan approximately 20 meters. Length approximately 21 meters. Weight approximately 7,000 kilograms empty. Current weight approximately 15,000 kilograms. The cargo is a Tetrarch light tank, 4 tons of armored vehicle, sitting in a wooden glider, being towed across the Rhine River into German-held territory. Inside the glider, 2 pilots struggle with the controls. The aircraft is barely controllable. The weight of the tank shifts during maneuvers. The glider responds sluggishly to control inputs. Turbulence from the bomber's prop wash makes the ride violent. The tow cable jerks and slackens as speeds fluctuate. The pilots are experienced but exhausted. They have been flying for 30 minutes. The landing zone is approaching. Soon they will release from the tow and attempt to land a flying barn containing a tank. At 945 hours, the pilots release the tow cable. The glider is free. It descends toward the landing zone. The descent is steep. The glider has no engine. It has no power. It glides at approximately 100 knots. The pilots aim for a field marked by pathfinders. The field is small. The approach is obstructed by trees. German anti-aircraft fire rises from positions nearby. The pilots ignore the fire. They concentrate on the landing. If they crash, the tank is lost. If they land too hard, the glider breaks apart and the tank is damaged. The landing must be precise. The glider touches down at approximately 100 knots. The landing skids contact the ground. The glider slides across the field. Grass and dirt spray from beneath. The nose stays up. The tail drags. The glider decelerates rapidly. After approximately 150 meters, it stops. The pilots open the cockpit. They are alive. The glider is intact. Behind them, the tank is undamaged. The mission succeeds. A 4-ton tank has been delivered by air into enemy territory using a wooden glider. This should be impossible. But Operation Varsity proves it works. This is the Hamilcar, the giant glider designed to deliver tanks from the sky. The largest glider used operationally in World War II. The aircraft built from wood and fabric that could carry loads heavier than most bombers. The flying barn that fought at Normandy, Arnhem, and the Rhine crossing. The improbable solution to the impossible problem of airborne armor. To understand the Hamilcar, you need to understand both the problem it solved and the audacity of the solution. Airborne forces in early World War II had critical weakness. They lacked heavy weapons. Paratroopers jumped with rifles, machine guns, mortars. But they had no artillery, no armor, no anti-tank weapons beyond what soldiers could carry. When they landed, they were infantry only. If enemy armor counterattacked, paratroopers had minimal defense. This limitation made airborne operations extremely risky. The British recognized this early. After observing German airborne operations in Crete in 1941, they understood that paratroopers needed armor support. But how do you deliver tanks by air? Parachutes could not support the weight. Transport aircraft could not carry tanks in their fuselages. The solution was gliders, very large gliders, gliders that could carry vehicles. In 1941, the British Air Ministry issued specifications, a glider capable of carrying a light tank or 40 troops or equivalent cargo. The glider must be towable by existing bombers. It must be buildable by non-aircraft manufacturers using simple materials. It must be disposable. The glider would be used once and abandoned. Cost must be minimal. General Aircraft Limited won the contract. They had built smaller gliders successfully. The Hamilcar would be their largest design. The prototype flew in March 1942. The tests were terrifying. The glider was enormous. The handling was poor. The structural strength was barely adequate, but it flew. It could carry a tank. The Air Ministry ordered production. The Hamilcar specifications were remarkable. Wingspan 68 feet, approximately 20.7 meters. Length 68 feet, approximately 20.7 meters. Height 20 feet, approximately 6.1 meters. Empty weight approximately 7,000 kilograms. Maximum cargo weight approximately 8,000 kilograms. Total loaded weight could exceed 15,000 kilograms. This was larger than many bombers. The construction was wood and fabric. The fuselage was plywood over wooden frames. The wings were fabric-covered wooden structure. The tail was similar. Metal was used only for critical fittings and hinges. The entire glider could be built by furniture manufacturers. This was essential. Aircraft production capacity was limited. Using non-aircraft facilities for gliders preserved capacity for powered aircraft. The cargo bay was cavernous. Length approximately 8 meters. Width approximately 2.4 meters. Height approximately 2.7 meters. The floor was reinforced to support vehicle weight. The nose hinged upward. The entire front section pivoted up, creating ramp for loading and unloading. Vehicles could drive directly into the glider. After landing, they could drive out. The system was crude but functional. The landing gear was disposable. The main gear was a wheeled bogie used for takeoff only. After becoming airborne, the glider jettisoned the main gear. Landing was on skids built into the fuselage. The skids absorbed the landing impact. The glider could not take off again after landing. It was single-use. This was accepted as necessary compromise. The towing arrangement required powerful aircraft. The Halifax bomber was standard tow plane. 4 Merlin engines producing approximately 5,000 horsepower total could tow a loaded Hamilcar. But the performance was marginal. Fully loaded, the combination climbed slowly. Maneuverability was limited. The flight was exhausting for bomber and glider crews. The pilots had minimal control. The glider had standard control surfaces, ailerons, elevators, rudder. But the control authority was limited. The glider responded sluggishly. Large control inputs were required for small corrections. The weight of the cargo affected handling. A tank shifting during maneuvers could destabilize the glider. The pilots had to anticipate every movement and compensate constantly. The training was intensive. Glider pilots were volunteers. They trained on smaller gliders first. Then they progressed to Hamilcar. The transition was shocking. The Hamilcar handled nothing like smaller gliders. Its size and weight created unique challenges. Pilots practiced takeoffs, towing, releases, and landings repeatedly. The accident rate during training was significant, but the pilots who completed training were skilled. The first operational use was Normandy in June 1944. Operation Tonga, the British airborne assault. Approximately 30 Hamilcars participated. They carried Tetrarch light tanks and anti-tank guns. The mission was to seize bridges and secure flanks of the beachhead. The gliders landed during night. The conditions were terrible. Many gliders crashed. Some broke apart on landing, but approximately 20 survived intact. The tanks were deployed. The mission succeeded. The pilots' accounts from Normandy emphasized the terror. Landing a Hamilcar at night in unfamiliar terrain was nightmare. The gliders had minimal instruments. Visibility was zero. The pilots relied on instinct and training. Some landed in wrong fields. Some hit obstacles. Some crashed and killed their crews. But enough succeeded that the operation achieved objectives. The second major operation was Market Garden in September 1944, the assault on Arnhem. Approximately 50 Hamilcars participated. They carried tanks, vehicles, and supplies for the British 1st Airborne Division. The gliders landed in daylight. The German defenses were stronger than expected. Anti-aircraft fire was heavy. Several gliders were shot down during approach. Others were destroyed on the ground after landing. But the majority delivered their cargo successfully. Market Garden failed strategically. The British forces at Arnhem were isolated and eventually overrun. But the Hamilcar operations were successful tactically. The gliders delivered armor and heavy weapons. The equipment was used in the fighting. The gliders performed as designed. The failure was operational planning, not glider capability. The third major operation was Varsity in March 1945. The Rhine crossing, the largest single-day airborne operation in history. Approximately 40 Hamilcars participated. They carried tanks, artillery, and vehicles. The landings were in daylight. The drop zones were prepared by pathfinders. The coordination was better than previous operations. The gliders landed in designated areas. The cargo was deployed rapidly. The armor supported ground forces immediately. Varsity demonstrated the Hamilcar's maturity. The pilots were experienced. The tactics were refined. The coordination with ground forces was effective. The gliders delivered tanks directly into combat. The tanks engaged German positions within minutes of landing. This capability was unique. No other nation could deliver armor by air operationally. The statistics are revealing. Approximately 412 Hamilcars were built. Approximately 344 were used operationally. Approximately 200 were destroyed in operations or training. The loss rate was approximately 58%. This was acceptable given the gliders were disposable, but the human cost was significant. Glider pilots were casualties at rates comparable to bomber crews. The missions were dangerous. The survival rate was poor. The cargo carried was diverse. Tetrarch light tanks were common. The tank weighed approximately 7,700 kilograms. It fit perfectly in the Hamilcar. But other loads were used. Bren gun carriers, artillery pieces, vehicles, ammunition, supplies. The glider could carry anything that fit through the nose and weighed less than 8,000 kilograms. The flexibility was valuable. The Tetrarch tank itself was obsolete by 1944. It was lightly armed. Designed for reconnaissance, against German armor. It was inadequate, but for airborne forces, it was the only tank available. The Tetrarch could be delivered by Hamilcar. Heavier tanks could not. Therefore, the Tetrarch served. The combination of obsolete tank and giant glider was absurd, but it worked. The post-war assessment recognized the Hamilcar as successful specialized design. It solved the problem of delivering armor by air. No subsequent design exceeded its capability until powered transport aircraft became available. The Hamilcar represented peak of glider development. Larger gliders were proposed but never built. Powered aircraft eventually replaced gliders, but during World War II, the Hamilcar was unique. The surviving Hamilcars were scrapped after the war. Wooden construction deteriorated rapidly. The gliders had no peacetime use. A few were preserved in museums, but most were destroyed. The knowledge of how to build and fly them was lost. Modern attempts to recreate Hamilcars have failed. The skills no longer exist. The last pilots who flew them are dead. The Hamilcar exists now only in records and museum examples. The legacy is significant. The Hamilcar proved that air delivery of armor was possible. This influenced post-war airborne doctrine. Modern airborne forces use powered aircraft to deliver vehicles, but the principle was established by Hamilcar. Heavy equipment can be delivered by air into combat zones. The Hamilcar demonstrated this operationally. The pilots who flew Hamilcars were extraordinary. They volunteered for missions where survival was uncertain. They flew aircraft that were barely controllable. They landed in enemy territory with minimal preparation. Many died. Those who survived never forgot. The Hamilcar was terrifying to fly, but it was effective. That combination defined the aircraft. The comparison to other gliders is instructive. The American CG-4, a Waco glider, carried troops and light cargo. The British Horsa glider carried troops or vehicles. Both were smaller than Hamilcar. Neither could carry tanks. The Hamilcar was unique in capability. This uniqueness came at cost. The Hamilcar was harder to build, harder to tow, harder to fly, but it delivered capability no other glider could. The engineering was crude but effective. Wooden construction was simple. Non-aircraft manufacturers could build the gliders. This distributed production and preserved aircraft factory capacity. The design was not elegant, but it worked. The Hamilcar was tool designed for specific purpose. It accomplished that purpose adequately. The operational limitations were significant. The glider could be used only once. The landing destroyed the skids and often damaged the structure. Recovery was impossible. The glider was abandoned where it landed. This was wasteful but accepted. The alternative was not having the capability at all. Single use was better than no use. The weather dependence was critical. Glider operations required suitable weather. High winds prevented launches. Low visibility made landings suicidal. Operations were planned carefully around weather forecasts, but forecasts were uncertain. Missions launched into marginal conditions. Pilots dealt with whatever they encountered. The weather killed as many gliders as enemy fire. This is the complete story of the General Aircraft Hamilcar, the largest military glider ever used operationally. The wooden aircraft that delivered tanks from the sky. The solution to the impossible problem of airborne armor. The glider that fought at Normandy, Arnhem, and the Rhine. The aircraft built by furniture makers and flown by volunteers into enemy territory. 412 built, 344 used operationally, 200 destroyed, 58% loss rate. But the mission succeeded. Tanks were delivered. Airborne forces had armor support. The capability existed because the Hamilcar existed. Crude, dangerous, effective. The giant glider that made the impossible merely difficult. The pilots who flew them paid the price. High casualties, terrifying missions. Single-use aircraft that could not be recovered if damaged. They flew anyway. They delivered the cargo. They made airborne armor a reality. Their contribution is remembered by those who study airborne operations. But the general public has forgotten. The Hamilcar is footnote in aviation history. But the footnote matters. The Hamilcar proved that audacious engineering can solve impossible problems. Delivering tanks by air seemed impossible. Wooden gliders seemed inadequate. But the combination worked. Not perfectly, not safely, but adequately. War demands solutions. The Hamilcar was solution. Imperfect but functional. That was enough. The giant glider that delivered tanks from the sky. The wooden aircraft that carried loads heavier than bombers. The disposable weapon used once and abandoned. The terrifying flying barn that pilots volunteered to fly into combat. That is the Hamilcar. That is its legacy. Crude, dangerous, effective, forgotten by most, remembered by few, but historically significant for proving the impossible was merely difficult. The Hamilcar flew. The tanks landed. The mission succeeded. The gliders were destroyed. The pilots who survived never forgot. That is the story. That is the Hamilcar, the giant glider that made airborne armor possible.